I've made a video on distillation columns explaining the differences between the types, and for this design I have chosen a packed column because of low cost and high yield for its size. The disadvantage of the type is that it requires high precision control. The column is made from a piece of 28mm diameter copper pipe filled with stainless steel spiral prismatic packing. In this design I specify a length of 1500mm, which is quite generous. In my other videos I explain the idea of the isothermal section of a column where azeotropic distillation occurs. I ran a series of experiments with columns that had temperature sensors regularly spaced along their length and determined that for azeotropic distillation the isothermal section had to be at least 800mm long. I settled on a meter to give a margin for error and space above the packing for a mechanism to draw off liquid product. The column is unusually long and narrow, but its unique feature is the isothermal deflegmator. I explain what that does and how it works in another video. My first column didn't have one, and the 1500mm length was arrived at by observing that the 2 or 3 stages below the isothermal section that are hotter seem to occupy about 500mm. When I devised and added the isothermal deflegmator, I didn't know how it would work and positioned it to allow 1 meter of column above it for the isothermal section and draw mechanism which takes up about 100mm. That ended up giving 200mm of column or so below the isothermal deflegmator. On testing, it turned out that the deflegmator extracts heat faster and more precisely than I had anticipated, meaning that the heat loss from the column below it was less important. So although I haven't tried it, I think you could remove the bottom 200mm of the column, leaving it 1300mm long, with the isothermal deflegmator at the bottom rather than part way up. On the other hand, the isothermal deflegmator's capacity to remove heat is the limiting factor that determines when a pot still run is stopped. The extra length of hot column below the isothermal deflegmator does allow for a little more heat loss and a slightly lower end wash alcohol concentration in the boiler, though you can get well under at 1% anyway. So for now at least I'm sticking with the 1500mm length, but if you have a 1300mm piece to hand, I'd try it without spending the extra money on a new pipe. To make the column, fashion the column extension and draw point mechanism first, as described in my last video. Then invert the column and pour in the stainless steel packing. When it's full to about 60mm of the bottom, stuff in a stainless steel pan scrubber to retain the packing. The isothermal deflegmator is the part of the design that makes the difference. Without it, you'll struggle to get to 95% ABV, and with it you'll get over 96. A glance at the alcohol-water system phase diagram shows you what a significant difference that is. Achieving that high proof is technically rewarding, but I'm in two minds about how much difference it makes to the taste if you're using a fractionating column like this. What's not in doubt is that it gets rid of the problem of tails. A packed column has a narrow range of vapour flow rates over which it will operate, and this is determined by alcohol vapour flow in the isothermal section above the deflegmator. To maintain that constant alcohol flow rate as a batch distillation run progresses, you have to increase the boiler power a lot, and the extra heat produces more steam for the same amount of alcohol vapour. In a conventional setup, this steam heats the whole column, shortening the isothermal section, allowing less volatile chemicals to get into the product. The deflegmator pulls that heat out of the column, allowing the isothermal section to remain at the same temperature with the same alcohol flow rate, so that you get a pure Hart's product right to the end of the run. I have another video about the isothermal deflegmator and how it works. In essence, it's a chamber containing spirit which boils and draws heat from the column at a constant temperature. It is a cylindrical chamber 80mm in diameter by 300mm long, surrounding the column. It has a sight tube to allow the level of spirit in it to be seen, and above it there is a reflux condenser, a standard Liebig condenser, so that the boiled spirit is condensed and drips back down into the chamber and doesn't have to be constantly replenished. This reflux condenser is cooled with running water in the usual fashion. Any arrangement that meets these specifications will do. It needs to be wide enough to allow boiling off the surface of the column without boiling over, and I find 70 to 80mm is sufficient for this. For my first one, I used 3 food tins soldered together, which is why I came up with these specific dimensions. It is a bit of a lash-up, but so far it's held together for a couple of years. There are numerous other ways of making it, such as using a larger copper pipe with reducers at the top and bottom. I've also done it with a copper drinking water bottle, as are readily available from India. The reflux condenser is made from 15 and 22mm copper pipe. I use solder capillary fittings for this, as they are cheap for the smaller diameter tubes. The 22mm pipe is 450mm long and the 15mm one about 600. The fittings are 22x15x15 T-connectors. These fittings are not designed to allow the smaller tube to pass all the way through the connector to give coaxial pipes, which is what we want, so they have to be modified with a round file to file away the step on the inside of the smaller end and allow it to be slid over the pipe. The 15mm side connectors of the 2 Ts are then connected to whatever system you're using for cooling water. Cold water goes in the bottom and warm water out the top. I use plastic hoses that are softened by the warm water temperature and easily fold flat, so I angle the top connector 90 degrees down to prevent this from happening. You need to then connect this condenser to the top end of the deflegmator chamber. Mine runs parallel to the column proper and is attached to it with a wooden clamp so as not to conduct heat between them. The top of the reflux condenser is open to air, and it's convenient to connect a funnel with a small length of silicone rubber hose so you can fill the deflegmator by pouring approximately 95% alcohol into the funnel. I use 4 shots or heads from prior runs and fill it about 2/3 full. I do not insulate the column itself, but I do insulate the deflegmator because it only works properly when it's boiling, and insulating it means it gets up to the boiling temperature faster at the beginning of a run. The column bottom is connected to the boiler using any convenient method, and I cover that in my video Tight Still Build 1. You end up with a long, relatively flimsy column connected to what may not be a particularly rigid boiler lid, so you will probably need some other means to support it in a vertical position. For this I use a chain from the top of the column extension to a hook on the ceiling. I've used stainless steel spiral prismatic packing, which is quite expensive. It comes in a variety of sizes, such as 5, 6 and 7mm. If you're buying it for a narrow column like this, I suggest using the smallest size. I have also tried packing the column with fine washed gravel, which works, but I haven't tested it as extensively as I have spiral prismatic packing, so I cannot say that it will achieve the same results. In the next video I will turn to adjustment and tuning of the column.